All right, today we're diving into something wild. It's a system built with the complexity of a spy agency's codebook, but its target isn't some state secret. Nope, it's for predicting the lottery. We're going to see what happens when someone tries to build a machine to find order in pure, absolute chaos.
So you see this, right? It looks like a secret memo, some kind of covert dispatch. Case 3 still pending, C17 at 30 days equals critical. But this has nothing to do with spies. This is the daily briefing from an incredibly sophisticated engine designed to forecast lottery numbers.
And that's really the big question for today. How on earth do you get from a machine that just spits out random numbers to a whole world with its own rules, its own laws, and yeah, its own critical alerts? How do you even begin to build a system around something that's supposed to be pure chance? Well, let's find out.
To get our heads around this pattern engine, we first have to crack its code. It has its own unique language, its own internal logic, and it all starts with that cryptic message we just saw. So, let's do it. Let's learn the language. We're going to break down the core vocabulary of this system piece by piece, and I promise you, by the end, that cryptic message is going to make perfect sense. So this whole thing, it really boils down to just a few key ideas. Once you get these, the rest of the structure it just falls into place. Okay, the most fundamental piece of the puzzle is something called a cycle. Just think of it like this. Every single 3-digit number, from 000 all the way to 999, gets sorted into one of 22 different buckets. These are the main characters in our story, from C1 all the way to C22. Next up, we have the gap. It's super simple, and it's just the number of days since one of those cycles last popped up. But here's the crucial part. In this system's world, time creates pressure. The longer a cycle goes missing, the more pressure builds for it to finally make a comeback. And this is how all that pressure gets organized. The system sorts every cycle into one of 7 tiers based on its gap. So if a cycle hit yesterday, it's in T0, the active cluster. No big deal. But a cycle that hasn't shown its face in over 30 days? Boom, that's a T4, critical. This is literally how the system decides what to watch, turning raw time into a priority list. Okay, so we've got our basic vocabulary down. Cycles, gaps, and tiers. Now we get to the fun part. Let's see how these pieces are used to build a set of rules. The system runs on what it calls the 6 laws of movement. These are the core principles it believes control how these cycles behave. We've actually already talked about the core of Law 2, gap pressure. It's a really simple idea. More days equals more pressure. In that data from April 17th, cycle 17 is the perfect example. It's sitting at a 30-day gap, making it the biggest pressure point in the whole system. But, and this is a big but, not all the laws are quite this straightforward.
And this is where things get really, really interesting. Check out Law 3, the cluster window. It says that after a cycle appears, its chance of showing up again isn't a straight line. It actually peaks on day 3, hitting a 32% chance before it starts to drop off again. So the system isn't just looking for things that are overdue, it's also actively hunting for these very specific short-term windows of opportunity. But here's maybe the most sophisticated part of this whole thing. This isn't just a static list of rules somebody wrote down once. No, this system has evolved. And the story of its evolution tells you everything about how it actually thinks about prediction.
So it started out as version 6.0, which was basically a rigid, rule-based machine. If X happens, then do Y. Pretty simple. Then it moved to 6.1, which brought in probabilities. But the current version, 6.2, uses something called Bayesian meta-learning. And what that means, in simple terms, is that the system is designed to learn how to learn. It constantly updates its own beliefs as new evidence comes in.
And this right here, this is the huge philosophical leap. In the old system, when a prediction was wrong, that was a mistake, an error that needed to be fixed by adding another rule to the pile. But in the new system, a wrong prediction is just evidence. It's a valuable piece of new information that helps the entire model get smarter for next time. Failure isn't a bug, it's a feature.
All right. We've learned the language, we know the laws, and we understand the logic. It's time to go back to that cryptic briefing from the very beginning and look at it with new eyes. Let's decode this thing, for real, this time. Look at this priority table for April 17th. It's not a mystery anymore, is it? We see cycle 17 is at a 30-day gap, which we now know makes it critical because of Law 2. And look, cycle 11 and cycle 2 are right in their cluster window, with C2 hitting its absolute peak probability on day 3, just like Law 3 said it would. Even C10 is on its last day in that active window.
So that phrase, it looked like something from a spy movie, C2 day 3 peak. It suddenly clicks.
right? It's not just random jargon. It's a precise, data-driven conclusion based on the system's own laws. It means that according to this model, this specific cycle is in the sweet spot, its most likely window to appear again. It's all connected.
Okay, let's zoom out. What does a system like this really tell us? Because this is about more than just trying to win the lottery. It's a reflection of something deeply, deeply human. Check out this number, because it gets to the very heart of what this system is really doing. Its accuracy for picking the exact winning cycle, only about 32%. But its ability to predict the general environment, basically whether any clean, non-repeating number is likely to show up that day, is 71%. In other words, it's way better at predicting the weather than it is at predicting which specific raindrop is going to hit your head.
And that's really what this is all about, isn't it? This incredibly complex, logical, and evolving system is this amazing monument to our fundamental human need to find patterns, to create stories and meaning out of what should be just random noise.
Which leaves us with one last big question to chew on. In this relentless hunt for order, and our drive to build machines like this, how do we ever really know if we're discovering a hidden pattern that was there all along, or if we're just creating one ourselves, imposing it onto the chaos?